There we go. All right. So welcome everybody to today's seminar. I'm pleased to present Dr. William Little. He is a colleague as well as a friend, and he also was a former instructor of mine. I've had the privilege of learning several different skills from him, both in the field and in the classroom setting. He has 18 years experience working at BYU, Idaho as a professor. He's also worked at the University of Missouri. Is that correct?
But it's now Missouri.
There you go. And he also has worked for 6 years at the survey in Missouri as well. He has experience doing field mapping, geomorphology. He's worked recently working on describing cores for a survey that's being done for a mining company. He is a wonderful person, and I'm just very glad that he could join us. So we'll go ahead and turn the time over to Dr. Little, and thank you.
I can tell you some Ben stories at some point if you want me to. Ben was one of those students you really enjoy having, and even when we had field camp, he didn't want to climb. Kind of lazy. He didn't want to climb 3,000 feet every day up to his field area and back down. And he actually went out there, took a sleeping bag and his food, and he went out and he camped with the bears all by himself out in the middle of nowhere, just so that he could get more work done. But really enjoyed having him. So, okay, the presentation that I'm giving today, the title's up there at the top. Now, down at the bottom, I figured that since it was Veterans Day, I might as well act like I were a veteran, put up all my medals and my ribbons and things. And by the way, if there are veterans in here, very sincere. We do appreciate the service. I didn't serve, but my dad is a World War II veteran, and I'm very well aware of the kind of sacrifices that are made. No, the reason I put all three of these things up here is most of the work that I did with this project was done while I was at the Missouri Geological Survey. And then actually the focus of this talk is going to be the big controversy that I created during the years that I was there, and it's still kind of ongoing. The bulk of my career, spent almost 20 years at BYU, Idaho, retired a couple of years ago, a little bit early. We have a couple of sons who are geologists, and we thought it'd be kind of fun to put together, excuse the pun, a little geological company. And we thought that sounded a little bit too cute, so I put my initials at the beginning of it. But we're trying to get basically a kind of a geological training company and some other consulting things. But that was an opportunity to work with the kids for a bit. And I was just telling Ben a little while ago, I've got a granddaughter who has decided she wants to be a geologist. A couple of summers ago, we were at the beach, and I told her, well, maybe when you get a little bit older, I can help train you. And she turned around and started to run away. She said, if you're not dead yet. And so anyway, but okay, the talk, I titled this thing, a reexamination of Pennsylvanian filled sinks, sink deposits in East Central Missouri. Are they Pennsylvanian and are they sinks? Now, needless to say, that could create a little bit of controversy. And actually, the main focus of this talk is actually this second part down here, applying new concepts to an old interpretation. We all have a tendency we come up with this great new idea, and then at some point it doesn't work out very well. But at what point do we let it go or do we just keep holding on to it? And I've noticed in my career that often, despite the amount of data that might be presented against a particular idea, we just can't let it go. And this is kind of a talk on applying the scientific method and not getting too entrenched in our ways. But I think the geology is very interesting in this. I was advancing a little while ago. Have to push this one first. So I have always had a very special association with technology. That's the way that one of my fellow faculty members put it at BYUI. And one time, a projector bulb went out, and we're having a department meeting, and he asked, "Was Little in the room?" And actually, I was. So right, is that press escape? So I can do it manually, but oh, there we go. Okay. All right. Now you've already seen half the talk though. Okay. All right. So the first time I gave this presentation, or one similar to it, was actually in 2004 while I was at the Missouri Survey. I had just accepted the faculty job at BYU, Idaho. As an employee of the state, technically you're supposed to get permission before you give a talk at a meeting. I didn't do that. I figured, what are they going to do? Fire me? I'm about to leave. But for 6 years, I'd been trying to get a few points across here and was having trouble doing it. And I thought, well, maybe if I go to a very public place and I present this, then they will start to listen a little bit. And it seemed to have worked. But it caused a lot of controversy for the whole 6 years I was there. You thought that I was giving a talk asking, are they really sandstone and are they actually in Missouri? And it was something that didn't go over entirely well. But it's improved since then. Okay, the study area, this yellow rectangle here is where these deposits are located. I'll be discussing. The red rectangles are the places where I actually did some field work. This is in the lake, or the Harry S. Truman Reservoir area. That one is Lake of the Ozarks, and then this is an area along the interstate, more or less, between Fulton and St. Louis. We're dealing with these deposits that are called Pennsylvanian filled sinks. Here's a little chart where they try to document most of them. There are actually over 1,000 of these things. Most of them are very, very small. You can see the kind of dots. And down here at the bottom, there are quite a few different types. Some are filled with fire clay, some are filled with coal, others have both, some are just sandstone. The ones that I'm going to be focusing on are these ones in the lower right here, the ones that are sandstone, shale, and dolomite, or just sandstone. Sometimes it can be mostly dolomite. And a lot of times these things are called blossom rocks. There's an example of what one of those blossom rocks looks like. And these, again, they're isolated. Very little continuity between these, and they're scattered over a very wide region. Okay, so first of all, what I'm going to do is I'm going to go through, oh, it's kind of blurry on the left. I'm going to go through the evidence that has been used for, about 150 years now to support the idea that these things are sink. Oh, my wife told me to take my hand off of the microphone. That these are sinkhole deposits and that they're Pennsylvanian in age. So we'll go through that part of it first. And one of the things is their geometry, their map outline. Most of them are small, and you see several of them here, and they're isolated from one another. Another little map over there. These are a couple of the maps that were done by my colleagues when I was at the Missouri Survey. From year to year, there were 4 to 8 of us that were out mapping, and we would each map 2 quadrangles a year, which requires 75 days of field work per quadrangle. That was probably tough, labor for me to be out in the field that much, and I actually loved it. But as you'll see as we go through here, it's very difficult for me, or was, to refer to these things as Pennsylvania. Well, I'm going to mention Pennsylvanian. They're Mississippian rocks on top of it. And if you know the stratigraphic column, it's very difficult to put Mississippian rocks on top of Pennsylvanian rocks in an undeformed succession. And so we came up with a compromise. So over here, you'll notice that these things are called SU. That's sandstone undifferentiated, or unidentified, sandstone unidentified. But we gave it the color of Pennsylvanian, so that someday we could conveniently just change it over here to PU, Pennsylvanian unidentified, and we could transfer it over. But we again, for the whole time I was there was some controversy. Okay, so evidence supporting the sink fill. One of the ideas of these things being filled sinks is that they had kind of a chaotic behavior to them, especially over here toward the margins, where the rock is broken and it's often dipping toward the center of this circular form. So the thought here is that the sandstone was on top, a karst environment was formed in the dolomites underneath. These are almost all entirely on Ordovician dolomite deposits. And at some point, it collapsed, and the Pennsylvanian rock fell into the sink, forming a collapse feature. Stratigraphic position is another one, and actually this is where I'm going to argue against it here in just a little bit. Again, almost all of these are sitting on top of Ordovician dolomites. Occasionally there's a sandstone down here. This is the Rubidoux sand, or the St. Peter sandstone, if you're familiar with that one. But on our maps, we often have these very bizarre, I refuse to do this, but look how that's cutting all the way down through this. You've got these tiny outcrops, and it's cutting down through tens or even more than a couple hundred meters sometimes of Ordovician rock to form the sink fill. Other times they're a little bit smaller, but the idea here is that these were the first identified sandstone on top of Ordovician rocks, and up until this time, the earliest sandstones that we had identified in Missouri were of Pennsylvanian age. So if it's a sandstone and it's on top of Pennsylvanian, or on top of Ordovician, it therefore must be Pennsylvanian, was the argument. So that's where we use the stratigraphic position. Some other things, the compositions of these, I showed you that diagram earlier that indicated that there are a number of these. Now, some of them probably are Pennsylvanian. I'm focusing on the ones that are filled with sandstone. The ones that have coal in them are probably not Ordovician in age. How much coal do we have from Ordovician strata? When do we get our first land plants? In the Devonian, right? And so obviously the ones that have coal, such as the one that's illustrated down here at the bottom. Okay, my technological challenge is showing up here. Okay, this one here is not going to be one of the older ones. This one here probably is Pennsylvanian. A lot of them are filled with these refractory clays, and the clay composition does tend to change from the northwest down toward the southeast. And I think that even a couple of these that have the coal do have Pennsylvanian fossils in them, and with those, there's no controversy. So how do they form? So that some of these diagrams go back, quite a way, 1916, 1906. I think that they were first identified in 1885 or something along those lines. There have been a number of explanations as to how these deposits were produced. I actually kind of like this one up at the top where we've got a karst surface that was later filled in with sand. It's just the age that I'm concerned with there. And this one, it's a typical, more of our textbook karst type situation where the carbonate rock is dissolving, and we have other rocks that are on top, and then they're caving into the new collapse feature. Now this one here, again, is very similar to, sorry about that, not using this control, to the type of thing that we see in our introductory geology textbooks, where we've got dissolution along the water table. It enlarges. Eventually, there's a collapse, and in this case, the Pennsylvanian rocks would fall in. Another idea for some of them is that the dissolution in the subsurface and the filling are contemporaneous with one another. And so you're basically just getting the beds, and this explains some of that dipping toward the center. The older beds begin to dip as the newer beds are deposited on top. So just a little bit of that background. Okay, so here's where the controversy begins. So I caused trouble both my very first day in the field with the survey and my very last day in the field. I'll be talking about both those here. This one, I had just been hired by the Missouri Survey to map the geology surrounding the National Guard sites in the state. One of my colleagues, a guy named Hal Baker, was supposed to introduce me to the stratigraphy. We had just come from Utah at that point. Actually, I just finished my PhD at Colorado, and I wasn't familiar with the stratigraphy in the state of Utah. Now, this is another part that's very hard duty. I was mapping the shoreline of Harry Truman Reservoir. So we're in a boat, and we're floating along the shoreline. And as we're doing so, we're looking at this unit over here. It's Ordovician. This is the Cotter dolomite, and it's just forming this nice continuous bed just all along the shoreline of Truman Lake. And then all of a sudden, here are these vertical or near vertical boundaries, and there's a whole bunch of sand and gravel that's present within. This was my introduction to Pennsylvanian filled sinks, which is what that little symbol means right there. And I asked Hal, I said, what is that? And he says, "A Pennsylvania filled sink." That's interesting. Let's go look at it. We got out of the boat. We examined it for a while. I was satisfied, and we got back in the boat. This is the same outcrop from another angle. So here are the two margins. There's the sand and gravel in the middle, the Cotter dolomite. And I want you to look at this one up here, though. We got in the boat. We went another 50 feet down the shoreline, and I said, "How? There's a problem. There's a Mississippian limestone sitting on top of your Pennsylvania filled sink." And so we thought about it for a while, and Hal finally decided, well, probably what happened is this was the margin of the river. The river undercut beneath the limestone and then backfilled. And so we just happened to have a little chunk of Mississippian limestone sitting on top of the Pennsylvanian filled sink. The problem is, by the time I finished mapping this quadrangle, I had a dozen of these places where the Pennsylvanian just happened to have cut underneath and backfilled beneath the Mississippian. So we're starting to see a bit of an issue with that. Okay, then so later I went back to this outcrop. I wanted to examine it a little bit further and look at the facies, being a sedimentologist. And this is that same outcrop again. Get a little bit different angle. Down at the bottom, we have gravel. The bulk of the deposit is composed of sand. I know it's really not overly visible in this photograph, but it's primarily trough cross-bedded. And then at the top of the sand has ripple bedding. Okay, does that sound like something that chaotically fell into a hole? Or does it, do we have any facies models that we might be able to tie something like that to? It sounds an awful lot like a stream fill. Okay, those pictures were on the north edge of Truman Lake. As I continue the mapping, I'm down on the south side now. A very interesting outcrop. Okay, here's that Ordovician dolomite, or down at the bottom again of the Cotter. Then up above is the Shoto group, which is a Mississippian limestone. And here there's no problem because it's limestone on top of dolostone. We simply have an unconformity here. So we're missing about 100 million years of history. Now, over a period of 100 million years, are you going to expect everything between those two boundaries everywhere to be the same? What's going to happen during that time? Can sea level go up? Can sea level go down? Can the land go up? Can the land go down? So maybe along this boundary right here, there can be a lot of different manifestations of what happened during that 100 million year hiatus. So I'm going to talk about this one here in just a moment. Okay, so these next two photo slides are going to be these rectangles. Here's just a close-up of that boundary, which to me looks like it's essentially a karst surface. And so this was a surface that was exposed. It was weathered. There was erosion. There's kind of a green clay that is present on a lot of the surface right here in this area. And then we go a little bit further to the left. And in between these two, now instead of so here's the limestone that we're just looking at. Here's the dolostone. Then in between is this wedge-shaped conglomerate that pops up once in a while in this area, and it's been called the Bachelor Formation. And so whether that's actually the Bachelor, I'm not sure. But the point is, there's some heterogeneity in this region in between these two stratigraphic units. Here's a close-up of the conglomerate. And then just to kind of look at it again, there's the surface, and then right here we've got that wedge. Okay, so we're still at Truman Lake, and in this, so we've looked at the north, we've looked at the south. This figure is taken a little bit east of the lake, and in this instance, here's the dolomite. There's the dolomite right there, just out of the picture. There's more dolomite, almost vertical boundaries. So once again, we've got dolomite at vertical boundaries, and then this material here, the white, is a quartz arenite. It's a very quite a pure quartz sandstone that's filling in these spaces between the little dolomite pinnacles, I guess you could call them. A close-up. This is the little rectangle that was off on the right. And again, there's this one is pretty friable, very poorly cemented, but there is some trough cross bedding that is present once again. So I thought, well, might as well go over to the west of the lake. To the west of the lake, I found some more of this conglomerate that we're calling the bachelor that's in between the two. So the point is, there's a lot of stuff that's going on between these. It's not just a uniform layer cake kind of a solution. Okay, that was the Truman Lake area. Now we're going to skip over to the eastern side of the state, in that area between Fulton and and St. Louis, where these sinks are a little bit different. Here we're starting to pick up some of the dolomite. So this outcrop has been referred to as a Pennsylvanian filled sink. Down at the bottom is the Cotter dolomite. It's got that same karst kind of a surface that we saw over by Truman Lake, but in this case, above it, instead of that nice clean sand and characteristics of the fluvial system, there's interbedded sandstone, mudstone, and dolostone. Now, again, how much dolostone are we going to expect to find interbedded with fluvial deposits of the Pennsylvanian that are going to then fall into, in a very organized manner, into a sinkhole? And so, as I'm mapping all this stuff, now it's kind of, the reason that I'm over here is they got tired of me causing trouble over in the other place. They kept trying to give to me the quadrangles that didn't have these sandstones. They would keep those for themselves. And so I had to start bootlegging. And I would, sometimes make this roundabout way. My quad's over here, so I kind of come into my quad in that direction and pick on other people's sandstones and things. But here, I had a bit of an issue with this one being one of these Pennsylvanian sink fills where, it looks like a channelized system, very possibly tidal in this case, some tidal channels, and but interbedded with the mudstone and then the dolostone. When I'm not aware, at least in Missouri, of any Pennsylvanian-aged dolomitic rock. So I'm going to show just a close-up of that there so you can see it a little bit better. Notice that this outcrop is actually capped by dolostone. And then there are these lenses of dolostone that are present within. The rest of this is interbedded sand and mud. And just one more, just a little bit close-up so you can see it. And interestingly, not far away from this outcrop, there is this down here is the Ordovician-Everton formation. Well, it looks very much like this Pennsylvanian filled sink. This is just across the street from the earlier picture the previous picture I showed. And notice they look very much alike. And for some reason here, we can accept that it's Ordovician. And up there, we want to call it Pennsylvanian. And I'll show you the reasoning for that here in a moment. And they're actually quite close to one another. This is the second photo, the one that's the Overton formation that's accepted Ordovician. And over here at Cave Hill Road, these are the stratigraphic columns form, is the one that has been interpreted in the past as a filled sink. Okay, here's one of the bootlegging things. This is one of my colleagues' quadrangle, and I asked Edie if she had seen any nice sandstones lately, and she made the mistake of telling me yes. And she said there's one of these nice filled sinks in this little gully right here. So I went and I looked at that, but then I mapped it out. I started to hike laterally, and what we actually have here, right here in the middle, where you see the photograph, there are 4 lens-shaped deposits that have these pinch outs that extend into the dolomite succession. So it doesn't really have that filled sink geometry to it. This one actually is very clearly interbedded with the dolomite succession. So this is accepted as Cotter, that's accepted as Cotter. The sandstone that's in the middle, if we accept that this is just a filled sink in the middle, would have to be Pennsylvanian. So then I started looking around this again. I'm driving through everyone else's quadrangles in these now. Often the sandstone, there's a sandstone that forms the upper layer of these filled sinks, and they refer to that as rim rock. So here's the Pennsylvanian sandstone, and on top is a great big pile. And this is a blanket that goes as far as you can hike back into the trees here. This is chert that has Mississippian fossils in it. This is a residuum from the Shoto group and a couple of other Mississippian limestones that were on top. And this whole hill, it consists of this Mississippian chert. A lot of crinoids are present from the Mississippian period, and the Pennsylvanian underneath. There's a close-up of it. And so, even if this is just debris residuum, somehow you have to get the older rock on top of the younger rock. And yeah, I got carried away. None of these is a quadrangle that I mapped. And but in every one of these, Pennsylvanian, Mississippian residuum, Pennsylvanian, Mississippian residuum, over and over and over again, in a wide belt across the middle part of the state. And so I'm a little bit concerned about that. This is the final one. Okay, this is my very last day in the field with the survey. We're doing the field checks. We're looking at each other's quadrangles and trying to verify the mapping that we've done. In this case, we're in my supervisor's quadrangle. And as we're doing the field check, he pointed out this beautiful Pennsylvanian filled sink deposit. I said, Mark, there's Mississippian residuum on top of your Pennsylvanian filled sink. And at that point, he looked kind of exasperated and got a look on his face. And he said, these have been called Pennsylvanian filled sinks for 150 years. Who are we to change it? Was what was the response? Obviously, we're the mappers, we're the geologists, we're the scientists. This is where something really kind of hit me. I'm thinking, okay, why am I looking at this so much differently from everyone else? And I was actually the only geologist at the Missouri survey who had not gone through the same bachelor's and master's program. So all of them had gone through their degrees being told and going on field trips and seeing that these things are Pennsylvanian filled sinks. And I don't know what I would have thought if I had gone through the program, but I'm just this guy who came hopping over the Rocky Mountains and showed up on the scene. I didn't have that preconceived bias, and so I was looking at things a bit differently. And I don't want it to come across that I'm trying to suggest that these were not good geologists. We had some excellent geologists with the survey, but it's just why would we look at things so differently? And I really think that a lot of it had to do with simply we had different backgrounds. But so my very last day in the field, I'm causing trouble once more. And it was very shortly after this that I gave the talk for or at GSA. And when I was giving that talk at GSA, I felt a little bit bad. My supervisor, the assistant state geologist, in the government, you have lots of layers of supervisors. He was sitting in the back. He basically came in because he wanted to hear what kind of nonsense I was going to dispute there. I showed this slide here. Okay, the dark green is Pennsylvanian, the pink is Devonian, the blue is Mississippian. Does anybody see a problem with this map? The Devonian and the Mississippian are where with respect to the Pennsylvanian? They're on top of it. Okay, even on our geologic map. And at this point, there was a room about this big. Everybody kind of broke up in laughter. My supervisor, I felt bad. He got up and he walked out. But later, when I saw him at the booth, he was staring at the map and he said, well, maybe we need to look at this. So it had made an impression. But again, as even here where we've done our mapping, we're showing the stratigraphic column out of order. And this is flat stuff. We're talking 1 to 2 degree dips coming off of the Ozark Plateau. This isn't the Rocky Mountains where we've got overturned beds, the kind of stuff we made Ben map. Okay, so we went into the excuse phase. Okay, how can we make this thing work and keep these things as Pennsylvania? And so we'd already had the Mississippi limestone is there. We undercut it. We backfill it with Pennsylvanian material. We shot that down. So the suggestion is that, well, we have glaciers in Missouri. Maybe these are glacial deposits. Well, a couple of problems there. One, we're way too far south. You have been influenced by glaciers. But the other thing is they then made the mistake. They got me completely out of that area. My last quadrangle, they sent me way up north into the glacial terrain where there are none of these sandstones. And so I got looking at the glacial stuff. I wasn't done yet. Up above, this is a close-up picture of some of that Mississippian residuum that I was showing to you. It's almost entirely chert. It's very angular. Most of the clasts aren't much bigger than than cobble, or maybe small boulder. Okay, the glacial material up north, okay, that's a granitic boulder. Okay, all of the bedrock up there is sedimentary. It's limestone and shale for the most part, primarily limestone. Don't even have the dolostone up there. And here's a chunk of granite. And over here, all kinds of rocks that have nothing to do with the geology up there. There's a quartzite sitting in this moraine over on the right. So the composition is very different. The geometry of the class are very different, and we're too far south. Okay, so we gave up the glacial idea. So then the thought was, well, what you're looking at is down here's a valley that's got Pennsylvanian rocks, and a fault has uplifted the stuff on either side. So you've got Pennsylvanian rock that's higher than Mississippian rock that's higher than Pennsylvanian rock, and it's being eroded and washed down, and it's forming a residuum or maybe a stream deposit along the margins of the Pennsylvanian. And so some of it just happens to be on top, and that's why it's all residuum. Yeah, we're getting very creative now. For that to happen, you'd have to have basically a ribbon-shaped deposit, or something that's narrow, and it's going to be in a band and run along just the margins of the Pennsylvania outcrops. And you need to have the faults so that you can have basically a graben that's present there. And looking at sediment too. So this is the stuff that we tend to find that's associated with streams. And so composition's almost the same, much better rounded and so forth. But we finally gave up that one. Okay, so this was the last attempt. Notice I have no picture here because I don't know how to draw this one. The final idea was, well, what we got is we've got a huge karst system in the subsurface. Basically, we have an underground river system that's huge, that's running across the entire state, and it's being filled with Pennsylvanian sand. It's happening to the Pennsylvanian. And that's the one where I kind of threw my arms in the air and I gave my talk. Okay, so that's the stuff that they were using, and some of my counter arguments for justifying this as Pennsylvanian filled sink. So I started to come up with my own alternative model. And one of these is I'm looking not my quad. I noticed that in this area down here, it's not like this everywhere, but as we get toward the south and the east, these sandstones tend to all be found on the crests of ridges. And you notice in its cross sections here, they're all up at the top. And this one, we're starting to pick up some of the St. Peter sandstone underneath it. But they're still taking these things and they're cutting them way down into the dolostone. And so I was wondering, well, why over here are they all on the ridge tops? And so looking at the geologic map, okay, that last picture is taken over in this area here. Okay, the green, okay, that's the Pennsylvanian filled sink, and it doesn't look very much like a filled sink here. It looks a lot more like what? It looks like a drainage pattern. And so I'm really wondering if what we're and I haven't done any research on this, so this is just a supposition at this point. But I've come to wonder if down here what we're looking at is inverted topography, where the carbonates have been washed away, the sandstone has been left behind. It's fairly well cemented in this area, and so we're looking at maybe an exhumed. And again, this one here you could probably shoot me down on, but that's something I've wondered about. Maybe we're looking at an exhumed river system over here. The blossom rocks, I think that we're talking about before, are mostly in this area. This is Truman Lake, and that's Lake of the Ozarks. That's where some of the other pictures were taken. So that was just this is the same picture I showed before, just a close up of that pattern, and you can see the older rocks on top once again. Okay, and so also as part of this alternative model, I already showed you that one picture where we had the trough cross bedding, the ripples at the top, the gravel down at the bottom. It looked kind of like a stream deposit. That was over by Truman Lake. This picture here is just around the corner where we saw the interbedded dolomite and sand and mud. And the reason that they had called that one Pennsylvanian rather than Ordovician is because around that corner, this is Cave Hill Road, around that corner, there's that sandstone right there, great big sandstone. Here we have interbedded mudstone and sandstone. It's pretty much horizontal this way. And then here is the dolomite again, the Cotter dolomite, the vertical boundary. So this one here to them was clearly a filled sink. And so if this one's a filled sink and it seems to be time equivalent to the stuff around the corner with the dolomite, that must be a filled sink as well. And that's where we get that interpretation from. And so I'm going to show you a couple of close-ups here. First, the sandstone on the right, and then the mudstone. Even before that, this is that same outcrop just from the other side. That's the dolomite. There's the vertical boundary. Here's the sandstone. Notice that sandstone has a lens shape to it. And then the horizontally bedded sandstones and mudstones. And so this is the rectangle that had A. This is the sand, mostly trough cross-bedded. And next to it, this is the interbedded mudstone and sandstone. Any sedimentologist in here, does this look like anything that might be familiar? It looks like a fluvial channel and overbank deposits with, in this case, probably a crevice splay. So again, some of these deposits are beginning to look pretty much like part of a fluvial system. This is a quarry that's not far from it. Once again, here's the sandstone at the top that they call rim rock. But then we've got all this interbedded mudstone and sandstone. There's another sand over there. We've got in this case, the typical or the common red coloring that we have with paleosols and such. That one there really looks like we've got some paleosol development in it. And so I'm really beginning at this point to think that we might be looking at a size valley fill. So instead of karst. Now, not all of them look like that. Here's another one of these. This one is over close to the capital, Jefferson City. And in this case, we have mostly trough cross bedding overlain by parallel laminations and maybe some ripple bedding up at the surface. Okay, does that sound like another facies model? Sounds like a shore face system. We might be looking at a beach in this case. And these deposits, the ones that have this set of facies, tends to be a little bit more laterally extensive. And they tend to be a bit thicker. But again, are we looking at an incised valley situation that was then backfilled, or is this simply that now as we're toward the east, the rock unit that's underneath the St. Peter sandstone, which is a shoreline and fluvial system. Okay, I still needed to address what's going on with the chaotic margins.
All right, Richard and Becca, go get your backpacks.
Here's one of these sandstones. It doesn't have the chaotic margin, but the dolomite underneath tends to form a bit of a syncline type of a structure beneath the thick sand. Okay, this is the same sand body. This is one side of the road. That's the opposite side. And there's the sand. It looks like it's being pushed down into the dolomite. And on the other side, we're missing the sand, and it's not. So that's probably just the sand body is ending before it makes it across the road. Could we, instead of looking at collapse, be looking at compaction? And if we compact it a little bit more, this is close to the city of Rolla, right here, right along the interstate, one of these chaotic boundaries. And looking at it, the dolomite is there, but it almost looks like a fault that's been broken and shoved down in. And so did that break and the sand fall into it while the sand was still unconsolidated, or was it pushed down in? And is this an example of differential compaction? Again, I don't. To me, it looks like compaction, but that's something again I'd let you argue with me if you wanted. The one place where I stand firm is the Mississippian limestone on top. That one I can't get past. Okay, and finally, in terms of evidence for these things, for their age, in 2014, there's a young man named Daniel Meehan that started to attend University of Missouri Rolla, and they ran across my abstract from that 2004 meeting, and he thought, well, this would make a fun master's thesis to see if we can use detrital zircons to determine the origin of these sand bodies, the Pennsylvanian versus the Ordovician, and to see if maybe in that way we can make a correlation. How am I doing our time? All right. Okay. So he up here, okay, this green up here This stuff is clearly, it's pretty much undisputed Pennsylvanian. Here we've got some channel sandstones that are running from the west to the east, but they're interbedded in this case with limestones that are just loaded with Pennsylvanian fossils. So there's little doubt that the rock up here in the northwestern part of the state is Pennsylvanian. So they took a couple of these incised valley fills that were known Pennsylvanian, and they looked at the detrital zircons to try to come up with a source area. Down below, these other red dots are where they sampled some of the Pennsylvanian filled sinks. Not shown on this diagram, they also took samples of some of the known Ordovician rocks, such as the St. Peter and the Gasconade dolomite, the Rubidoux formation, so that they would have something to compare them against. And what they came up with, or what he came up with, is over here, these deposits that are certain Pennsylvanian. They've got some fairly young detrital zircons in them that are Paleozoic in age. And then, 1.1 to, I think it is 1.4, something like that, billion-year-old zircons are present as well. And they don't have anything that's that goes way back into the Archean.
Well, let's see if it's open.
When we look at the Pennsylvanian filled sinks, we don't have the young, maybe a little bit right there, but for the most part, we don't have the very young zircons. We've got the intermediate age zircons, and then we come up with these really old zircons that are 1.8 to 1.6 to 1.8 billion years old. And then down below, this is the St. Peter sandstone, and they got similar results out of the Gasconade and the Rubidoux. Notice that the signature of these, quote, known Ordovician rocks is very similar to the signature of the Pennsylvanian sink. And so his conclusions were that, over here to the right, it says pretty much the same thing. In fact, this one here down at the bottom, here they've overlaid the Rubidoux with the Pennsylvanian filled sinks, and it's a very close match. We're up here at the Pennsylvanian rocks, and you're completely missing that peak there. And so the conclusion that he and his advisor came up with is that toward the end of the Ordovician, the Ordovician had consisted pretty much of an empiric sea, and then we started to get some of the shoreline and some fluvial deposits toward the end with the Rubidoux. But even though the end of the Ordovician globally was experiencing a sea level rise, this area appears to have been experiencing a sea level drop, so relative sea level drop. And if we go back, and so this they have correlated to the beginning of the rise of the Ozark uplift as part of the tectonic orogeny. And then what we have then is toward the end of the Ordovician, we probably are having some incision that's being backfilled. And so down here in this area where we saw those more continuous sandstones sitting on top of the St. Peter sandstone, you're a little bit closer to the paleo shoreline, or the direction of transgression and regression. And so you've got the thicker sands. When we get up in this area is where we really have the spotty sandstones. There's a dot here and a dot there and a dot somewhere else, and they're quite discontinuous. We're probably getting up toward the head of the incised valleys where backfilling can take place, and we can get these Ordovician sandstones that we now used to call Pennsylvanian. And then this area remained elevated for quite some time. There's almost no Devonian, just those little blobs that I showed in that previous slide, and we don't really start to get into significant deposition again until the seas. The seas go out, the seas come in, but they come back into the Mississippian, and we've got the Mississippian rock that's over the whole northwestern part of the state. So we now have detrital zircons that are backing us up on this, and thought it was kind of fun to see that. Okay, so in the end, what do I think? Yeah, it's probably not the best background for that slide, but I've gotten through this. So the pre-Pennsylvanian age, we're interbedded with carbonates. We've got the Mississippian rocks that are on top. We've got the Devonian and Mississippian that are on the geologic map. The fossiliferous residuum that's on top throughout the state. I won't go through all of it again. Here's a common friend in the state of Missouri, and you might have those down here as well. And the incised valley origin. Yeah, I'm not going to go through all that again. We've talked about a bunch of that. So anyway, so what do I think? First of all, things are very confusing. They don't know what direction they're going here. This is my wife's contribution. She wanted me to put this slide in, so I had to find a way to do it. I just did this one before we came. My thought is that these filled sinks, at least the ones that we call blossom rocks, there's some that don't fall into this category, are not Pennsylvanian aged. They're most likely Ordovician, correlated with the St. Peter sandstone. They're not collapsed features into sinkholes. I personally think that they're most likely incised valley fills. They tend to be more fluvial as we get away from the shoreline, and more shoreline and characteristic as we get closer to that area. And that's pretty much it. So any questions?
Are the littles today?
Well, thank you.
Good.
What's cool?
Is that bad?
But
Oh, it's not a phone call. So he's talking to some college students, and he's talking to them about geology stuff. So I'm listening to it, but he's busy talking to them. You might hear him in a minute again.
it's only $23.06 or so just to get everyone.
Yeah, Arbuckle. Okay, yeah, okay.
And those are the response of the kayaking kids that are they were
Yeah.
And we interpreted them. And with the aim, yeah, the problem with the inside molecule is hard to get.
Yeah, and there's there are no fossils in these. Oh, I'm supposed to repeat the questions. We're talking about I guess determining the age of these deposits. And
age data.
yeah. Yeah, and I could be convinced that there's something other than incised valley fills. I'm not, what I like about that one is we've got those vertical margins on the dolomite. But what here, we didn't have fossils to come up with the ages, and that's probably why it's taken this long to come up with a different age interpretation. But that's where the detrital zircons really came in. So the thought there is that for the Ordovician rocks, the source of the detrital zircons is basically the craton. And we've got the Grenville and the Superior region, and then a couple of others. But then when later, as the Appalachian Mountains are rising, then we get the younger Paleozoic zircons that are coming in, and we're finding those in the true Pennsylvanian rocks. And so what we've done here is we've correlated based on detrital zircon rather than on fossils. Oh. Yeah. Yeah. I don't think I ever would have convinced the survey to do seismic, but yeah. And yeah, I'd love to go back and do some of that. I think it'd be really interesting. Yeah. Yeah. So, yes. Yeah. And Well, yeah, I'm wondering if we're looking at a coastal situation where we've got some tidal influence. I wonder if some of those are tidal channels. I really don't know. I didn't look at them that closely. This field work was actually done a long time ago, and I was focused more on the stratigraphic succession, and it really wasn't until later I started to think about the depositional environment for that particular outcrop. But with the lane-shaped deposits, the interbedded sand and mud and dolostone, it makes me wonder if maybe it was coastal, at least, because you've got the carbonate in there, and they tend to be lens shaped. And that one at the top was kind of continuous, and I think that whatever incision took place for if it is an incised valley fill, came later, and so just around the corner of that thick sandstone that I showed, I don't think is time equivalent to those. I think it's much younger. And so I'm kind of dancing around it there, but I'm not quite sure because I haven't looked at it. I didn't look at it closely enough, to be honest. Yes.
Maybe you could mention this, but what do you look for you notice the deposit at where's the closest Ordovician?
No, it's in the east, it's directly underneath the St. Peter sandstone. So in the east, these sit right on top of the St. Peter, and I think they look just like the St. Peter in many cases. I think that they're St. Peter equivalent. I don't know. Well, they might be a little bit younger. It would be maybe the upper St. Peter. Now, as we move to the northwest, there is no sandstone underneath. They are, and that's where the interpretation came from of them being Pennsylvanian. They were the first sandstone above the Ordovician. And so they the only sandstone we know of that would fill that is Pennsylvanian up in that part of the state. But down to the south, to the southeast, they directly lie on top of the St. Peter. Yes. No, I didn't. My job was to make a geologic map, and I was already stretching it. But it's something I'd love to go out and do now. Now that I'm a free man, and I can do whatever I want. I'd love to go out there and do more of that, but that is something that would need to be done. So not the set structures. It was pretty much just textbook trough cross bedding, and what I found interesting though was the facies association, the order of the facies. That when we do find one of these, if there's gravel, it tends to be on the bottom, and then trough cross bedded, and up at the top, we'll often get the ripple. So you do have that fining upward in structures present within. And then some of those that are a little bit closer to where we're overlying the St. Peter had more of a shore face type of a succession associated with it, where you've got the troughs and then the parallel lamination and then maybe some ripples. They're mostly chert. So no, I don't. I think probably what they are is they're the material that was ripped up from underneath from the dolomite and then silicified. Is at least that's the excuse that I give. And some of those have this kind of purplish color to them, and they've decided, as he was the fancy Mozartite for Missouri. So if it was purple chert, in one of those channel fills, we called it Mozartite. Anything else? So, pleasure to be here. Thank you.
I think we're meeting in the graduate lounge if people would like to have for refreshments and for snacks and things like that. That invitation goes back to you.
Oh, hi.
I work on this Arkoma Basin, the Arbuckle.
Okay.
And actually